Hello all, Michelle Peltier from Alvin High School, going through a little bit of absolute value inequality solving, giving y'all a few pointers that could maybe help us out as we move through Algebra 2, getting our kids ready. So as you're teaching absolute values, the majority of the time, the kids don't have any problems. Y'all have done a great job. They know the absolute value of 3 is 3. If you're not talking about a difference from 0, that would be a great thing to talk about. Make sure that they understand. Some of them do, some of them don't. Could be because they weren't here, we understand. But if they talk about the distance from 0 being, that's why it's a positive, not just because the absolute value makes it positive. So then they could also see that if they took the absolute value of a -3, that its distance from 0 is also 3 units. Knowing that a distance being 3 units helps them out a lot with, not just being 3 units, being positive helps them out a lot. Hello all, Michelle Peltier from Alvin High School, going over a little absolute value inequalities today. Hopefully we can clear a little bit out of the air, make sure that everybody's on the same page, and we're all getting our kids ready to move up to the next level. Absolute values are taught well before they come to us in high school. And most of the time the kids, when they see an absolute value, they don't have any trouble telling us that that's going to be 3. Some of them do have trouble explaining to us why or how. So if you're not using the distance from 0 analogy, that would be great for you to pick up. They know that a distance is positive. So on the number line, 3 sits 3 units from 0. And then you could also talk to them about that's how they know that the absolute value of -3 would also be 3 units from 0. And since distance is positive, that's why this is positive. It's not just because we make absolute values positive. It also helps when they get to when we're looking for an x. So then they can also see from that number line, if they're talking about a distance from 0, and we say that distance is 3 units from 0, it helps them to see how we know that x is going to be 3 and x is going to be -3. But what we're asking today is that hopefully you will see that this being 3 distance from 0 and this being 3 distance from 0, we need to do more than just tell them that this number is going to be positive and negative. Because as they jump to that shortcut, it hurts them later when they get to the inequalities. So what we would like for you to do is talk about this being the number, the 3 or -3, being positive, or that number being negative. And if they solve that number, that's how they get to the -3 on the other side of 0. And what that does is it helps us when we get to these. So, and it keeps the kids from having to remember so many steps. Equations, it's easy. You're just changing one number. The problem is when we get to inequalities, we're doing more than just changing one number. So for example, if I have a greater than, and I'll keep it simple with this, and then I'll show you so you can see what our kids are having to do, so you can see the reasons why we want you to do this simple step. If we take this value and we want it greater than 3, we know that x is going to be greater than 3. That's a distance from 0, positive x greater than 3. But then we also want the negative x is greater than 3. And if they weren't doing this before, they would have to not only change the 3 to be negative, they would also have to change this symbol. So that's 2 things the kids are having to remember, and they don't really understand why. But if we talk about that distance from 0 being a positive and a negative, and that what's in the absolute value bars is that distance, they get a little bit deeper understanding. So this one's already solved. All they would have to do now, if we do it this way, when they divide by -1, it will automatically switch their symbol for them, and they will get that x is less than -3, along with the x is greater than 3 that they already had. It works whether it's greater than or less than. You have the first one as is. You have the second one, it's that distance from 0 less than 3. This one, no change. Didn't have to solve anything. When they divide by their -1, that will not only change it to be a -3, it will also flip that symbol. So that's less that they have to remember for each problem that they're doing. Okay? So let me show you what it looks like a little bit harder so you can see the validity in them needing to learn how to do this. So, very common problem that we would see in Algebra 2. In fact, we probably would start with one like this. Again, we talk about this being a distance from 0. So, x minus 1 less than or equal to 5. And I tell them the first one's going to be exactly as it is, just dropping the bars. The second one's where we do our change. And all we do is we change the stuff inside to become negative. That stuff that's the distance from 0 becomes negative. And we don't change anything else about the equation. All we do is drop the absolute values and make them parentheses. When we solve, they can add 1, and x is less than or equal to 6. On this one, they're going to distribute -x plus 1, less than or equal to 5. No change yet. Subtract their 1, -x, less than or equal to 4, and now when they divide by their -1 with their x, that gives them x, switches the symbol, and becomes a -4. So they can see that their solution would be between those two numbers. Same thing happens here. And notice the only thing I'm changing is that negative in front every single time. So take the stuff inside as is and solve. Take the negative of the stuff inside and solve. And that's the only thing they have to change. So when I add 1, they get 6. I distribute -x plus 1 greater than or equal to 5. Move my 1 over. -x greater than or equal to 4. When I divide by my -1, it not only changes it to become a -4, it also flips my symbol automatically. So they're not having to remember to flip the symbol and the number. It's just change the sign. Change the sign one time and it will take care of the symbol on its own. So let me show you one more that's more like what they're going to see more often in Algebra 2, possibly on the SAT Tech test, where they've got more stuff. So we have to teach them to get their bars by themselves. So notice there's a lot that they already have to remember. So they're going to move their 8 first. And when they add 8 to both sides, they're going to have 6 absolute value, 4p plus 2 less than 42. Then they know they can't distribute over absolute values. We've stressed that and stressed that. Then when they divide by their 6, they're going to now have their absolute value of 4p plus 2 less than 7. Now it's a simple problem, just like what we did a minute ago, and the only thing they're going to have to remember is, that's 2. Sorry. The only thing they're going to have to remember is to make a negative of all the stuff inside. And so it's a simple change. So when we solve, 4p subtract 2 is going to give me 5. When I divide by 4, I get 5 over 4. When we distribute, -4p minus 2 is 7. So -4p, add 2 and we get 9. When we divide by 4, now we flip our symbol and we get -9/4. So instead of having to remember 2 things, they're only having to remember 1. So thanks so much for watching our video. If you have questions, please reach out to one of your instructional coaches or one of the high school instructional coaches. Absolutely, we would love to help you if you're still struggling in this area. Thanks so much for your time. Have a great day.